What is up, Derek 13 Series Engineering here, and today we are going to be going through the next part. Oh, not focused. That's weird. Anyways, we're going to be going through the next part of our relationships and our CQRS API, which we're kind of getting a little divergent from CQRS and just going into relationship stuff. But something I wanted to do today and try and show everybody is this through relationship. Has one through and has many through. And this is a Laravel eloquent thing. But as you can see, what it's doing is what we have. Pull up our draw.io real quick here. What we have is, we have planets, they belong to system. We have stars, they belong to system, but what if we want to get planets and stars? Well, there is two things we could do. The first thing is, if we go to our serialization, we could add stars to the planet group, which would return stars. But remember last time, we already addressed the multiple queries thing, and we got it from 2 queries down to 1. So that would be adding an extra query, because then we're going to resolve stars. So that means we also would need to do a join to keep it to 1 query. So we need to add a join here for stars. But the problem is, one planet has one system, but one system has many stars. So our issue is that we would not be doing an inner join. We'd be doing an outer join or a left join. And that's a pretty negative query as far as performance-wise goes. You're going to have really bad performance with that type of join just to get that relationship. And the point of all this stuff is that we want to optimize this. We don't want to join stars here, but we could have a function like get with system with stars. We could pass some flag that it's like, if you want stars, then there's like a query parameter. We could use a query string DTO, and then we could have some logic like get with stars. So if you want the stars, it adds it, but it takes longer. System, we're not really having any performance issues with this by adding system, but when we add stars, and it goes to scale with lots of planets, lots of stars, big tables, we will have issues. So a great solution to that is through. And now we are going to have a separate query to do that. So we are going to be adding another query, but it's a way to get our relationship, even though planet and stars are not related. And it's also great because we don't have to get system if we don't want to. So we have like some added flexibility. If you just want to get the stars, we can just get the stars. And we're going to do this by adding a wrapper. And let me just explain this real quick, also partially for my own benefit. Planet service get, right, that just does get with system. This gets the planet and the system, and it does it in one query. If we just did find from the planet repository, the native find function, or any of those, that aren't collections, find one by whatever, that is going to get just the planet without the system. The system would be lazy loaded, and we wouldn't query the system at all if we never called get system. But if we go like this, planet, and then we're like get system. Okay, so now we got our system. And then we could be like stars equals system get stars. or, you know, whatever. I'm just explaining it. We don't have to do that. We could just boom, get stars. But what's going to happen here, and the reason why I broke it down like that, is that this is a proxy, or it was. Now it's no proxy class because we have one query. But let's say it was a proxy. It's going to resolve when we get stars. But when that proxy resolves, so that's 2 queries, then it's going to do a third query, which is get stars. Luckily, we're only at 1 right now because there's no proxy here. So we didn't do an extra query just by doing this. So it's already loaded. Get stars, that's going to be our second query, because stars, same thing if we did get planets. That's, stars is technically, that's a proxy class too. And we'd have to do like stars, first, like get name. Okay. And then it's going to load on that one. It's going to query and load all of them, or if we iterated all of them, it would load or whatever. But at some point in here, or at some point in serialization, if we added stars to the planet serializer group, it's going to resolve that relationship that goes through everything. You're going to get an extra query, and it might be pretty sizable because you might have a lot of stars in a system, or whatever it is, you might have a performance impact. So we're going to say from planet, you can't get stars. That's going to be a rule to our API. We're not going to allow that to happen, because it's going to be too inefficient. So because we have to jump through, all these hoops, and it's like, yes, we could do this, and we'll be at 2 queries. But the other thing is that there's not really any flexibility with this. Like, I have a planet, I have to get the system, I have to make sure it's done, using the function that we made with a join, and then I have to get the star. And so, like, now we have a kind of complicated, um, a more complicated way of doing this stuff, and this is all predicated on having access to system and all these things. Not that we're really changing that, but a different way to do this without having to load system at all. So we can just, what if we don't want system? We can just get rid of, system if we don't want it, and just get the stars. But how do we do that without loading the system? That's our issue. Let's say we can't load system, or we don't want to, we just want to get the stars for the planet, and we just want to have like stars. We're just going to return an array, or a array collection of stars. How are we going to do that in a more efficient way? And what we're going to do is we are going to, in our service, we're just going to do get stars. This is going to get the planet stars. That's all it's going to do. It's going to take the planets, it's going to return a collection. It's going to take the planet's ID, and then in our planet repository, we are going to have a cool function that we're going to make our own kind of abstract, like, based repository with. So public function get stars. What did they call it in Laravel? Just has many through. Does one planet have many stars? Potentially, yeah. So we can name it the same thing. Has many through, and it's going to take 2 classes. They did, the mechanic car one is a good one. So it has if you read this, blah, blah, blah. Okay, the owner. So we're getting the owner through the car. So for us, we're going to get the star through the system. Cool. Okay. Now we probably want to add like the ID for this someplace. Or we want to we need to know the system associated. We need like the actual system that the planet has, but we should be able to find that with just the planet ID with our query. I think we're gonna have to pass that unless we like initialize it in. I wonder how Eloquent is doing that because they need the ID somehow. Yeah, I'm not sure how the framework is actually grabbing that. Should probably read up on it, but can delete these without getting into all that. We can just pass the ID, and it'll be basically this is going to be like a generic query we're going to add to do all this. So let's add in repository. Let's just do like base repository, and it's going to extend this guy. That's for planet. We probably just need to. Oh. Yes, we do need to do that. We need to import this, and then we need to add has many through. We could also, and I thought about, we could also do this just as a trait, but I think it'd be better to just do it in an object-oriented way, like this. Cool. What are we calling this? The has class and the through class? And then, oh, is ID ever going to be something other than UUID? Do we want to pass like a criteria through it so it's not just an ID lookup, like it's a lookup through something else? Maybe in the future we do want to do that, but for now, I think just the easiest thing to do is going to be to pass a UUID, just like that. Oh, that didn't work. And then we can do our query builder stuff. From has class. Now we need some criteria. And let's think about how to do this. Well, this ID is not related to this ID is the planet's ID. Oh, we might want to do that kind of differently too. We might want to go, because we don't want to join on system. We don't need that. We just need stars where in maybe that's just regular where. Let's see, where in. I'd have to look that up. I think it's just in where there's and or we want to do an expression for in. Or is it just in? So I should actually, we should just be able to do like where x dot id in well, we could do equal because it's going to be, we're talking about system here. Yeah. Where x dot id equals id. That's fine. We don't need to do an in for anything. ID and ID, but this is not system ID, so this isn't going to get us, this is not going to get us the right thing. But if we just do another join, oh, you know what? We probably want to subselect. And that's how we can alleviate using a join. Subselect is going to give you better efficiency. So where we probably want a doctrine expression for that. I've never done a doctrine expression with Query Builder for subselect. Let's look it up. Subquery. Well, I've been going at this for like an hour and I can't get it to work with Query Builder with a subselect on a relationship without passing the entity. You can't pass an ID like this. You have to get the entity, and we don't want to do that because that's going to add a query. We're trying to do this without adding a query, just with an ID of a planet to get the stars with a through relationship without doing all the queries. So I don't really think there's a way to actually do that in DQuil because relationships are not based on the IDs of the entity. They're based on the actual entity themselves. So we would have to pass that. Or do a subquery. What we were trying to do with a subquery with an expression, we basically have two relationship. So it would be like a double nested subquery. One to get the actual planets, and another one then to get the system from the planet. So you're still, either way, it's just not an efficient thing. And this is definitely an extra thing, and this is why Doctrine doesn't really have this functionality. Is building it out with expressions, just it gets into some weird subquery nesting. But we're going to just do this with a raw query to get what we need, and there's nothing wrong with doing that, and it's actually going to be more efficient to get the stars that we're trying to get. So yeah, I think it was just spending enough time trying to do this with DQuery and Query Builder, you know, and doing this stuff with raw SQL, but still using some of the stuff for doctrine ORM. That's fine. You know, you don't have to use DQuery for everything, especially when it doesn't do what you want it to do. That's not an issue. So yeah. Anyways, I'm just kind of finishing building this out. What we're gonna do is we're getting the tables we need. The has and through tables, and of course, you know, we could map them or something, but you know, this is a good way to do this without knowing what they are, and we can be like select. Well, we're gonna get everything that we want. We're gonna change this from I might need to print this actually. I probably do need to print it. We can just go like that too. Select all from has table where from has table h where h.id in select t.id. Clean this up a little. Select t.id from instead of doing, well, yeah, we don't know what it's going to be, so that's fine. From through table, I guess I'm not going to need those. We'll revisit that. Where t dot, and here's the other thing, this ID has through from, we really need another thing here because this isn't going to work. We need like entity. Well, that's a good idea. Just trying to clean this up real quick. That's what that's going to be because we're passing right through. And this one is going to say that it's planets. Yes. So, it's funny they named it the exact same thing. Is there a get entity class? I don't know why I keep doing that. This entity resolve repository, blah, blah, blah. Yes. I could probably do. Let's do this. then we don't have to pass it. And sweet. Okay. Where t dot um, id equals um, id. Oh, this is going to be weird because it's backwards. I actually need a query. I need the select to get the, yeah, I'm doing this backwards, but that's okay. Quick fix. Okay, finally got it. I just had to take a little break to run through this stuff. But this is just done in a raw, um, in a raw Postgres query, but this is like the best way to do this. Dql will like not give us what we want, and I would love to recreate this in Dql maybe when I have some time with Query Builder, but it just doesn't seem possible. So we have select all from our star table where the star's system ID is in the planet's is in the subselect of planet system ID where the planet ID is the ID that we passed. And we just want to make sure there's no actual, yeah, this is all, so this is totally agnostic to planet, system, stars, all that. So we can use a through relationship for basically anything. If we had a stars endpoint, we could get the planets with our through relationship this way. This is a very efficient, very quick query where planet from planet E, yes, that's right. All that stuff's right. Cool. That's it. That's our has through. It does kind of suck to not do everything in Dql because that's what I wanted to do was do this all with Dql. I think we have a serialization issue where system's still coming back, but oh well. Um, Not a big deal. Um, we had to configure some stuff. I had some auto wiring issues, but it got that stuff sorted out. Um, But yeah, we could implement this in any repository now. Super easy. Like we could change that to planet and pass the star ID for our star endpoint. And there you go. And that's a great way to get a relationship when you just, and you don't have to build a direct relationship. It's a lot more efficient to do this. And it's like, yeah, in our planet endpoint, if we are like, well, planets and then um, our planet get and our ID. Now that's one query and that's going to have planet and system in there. And then this is a second query, of course. So is this, let's just take a look here. I need to add both of these. Get groups. Is this the wrong one? No. Oh, but I think, yeah, we have some group wires crossed here between stars and planets with system. I think that's our issue. Well, we're not using system there. And that's all stars. I don't think we should have an issue. But anyways, I'm just trying to make a point that planet and star. What if I just go like, is it supposed to be star or stars? I don't know. I think that context might have been causing an issue for us. Yeah, it seems like it. This should be done differently, of course, because we want to be able to dynamically set that. We could just take kind of getting out of scope here, but there we go. Should give us the same. Stars or star? Stars. Yeah. So cool. There we have everything. Again, system ID shouldn't be included, but either way, it's like this is what the full endpoint would look like. But we have to ask, is this really better? Because the other thing we would do if we're going to do something, if we're going to do this without the through relationship, we would go like stars and then planet get system get stars. That's the same thing, same exact thing. Well, same result, but a different thing. This is not lazy loaded, it's preloaded, but then we run from system, we run a dequal series, dequal statement to, system get stars, and then we load that. So it's basically it's serialized correctly that time. Interesting. I think it's because yeah, we'd have to fine tune the through to not do a select all, but do it like an array of fields or something like that. Or since we have the attributes, we could just get the serializer group and we could build that out so it'd be working pretty easily. You need to add a reflection class to this. Get the groups from the reflection class, and then that would be in your select. So that's just the one piece that's missing. It's like reflection, get the class attribute, or get all the properties for groups, and you know what I'm saying. We just have to iterate through the attributes and have the select be correct here. But maybe for another time we could take a look at that. But yeah, basically we have almost the same thing here because we have two select, we have two queries. We have this one and we have this one. So we're not really saving anything this way. But if there was a scenario where like get planet stars stars group, and it takes a planet ID, and this is like stars. Now, how are we going to do this? Well, this is exactly where our little dealio comes in here. This is probably like how this should basically stay. So yeah, there we go. So how are we? This is how we're gonna have to do this. We're gonna have to get our planet, which our get is using with system with a join. So that wouldn't be great. We'd want to do get, you know, without system. You know, a framework is all about adapting something to fit your needs. That's a great way to be successful using a framework. It's not just doing only what they say, but finding a way to, even though it might be a little more complicated at first, but finding a way um, to really get it to do what you want it to. And that all comes down to understanding, you know, what the framework's capable of and what it's not capable of. But anyways, you would have to do this. You'd have to get the planet, and then you would have to, so that's one query with a join, and then from system get stars, and that's another query. So there you go. That's two queries. There's a join in there, and that's the only way. And let's test it. And okay, there's just the stars for that planet. So that works, but it's, I don't know why that said 1,000 milliseconds. I think because it was like a fresh, you know, it wasn't warmed up, it wasn't cached, and now it is. But that can all be replaced by this. We're only getting 100 milliseconds there. I'm interested to see what this is like not cached. So if we go and change our stars ID, then doctrine should not have it cached, and this should be an uncached query. Oh, that's not happy. Oh, because I did it on the wrong thing. Shoot. Well, okay. That's what we're going with. Now, the one caveat to doing stuff like this, oh, that's not even the same. Now we should get this without it being cached. 111 milliseconds. I think it's still cached, but what if we try it again? Oh, it's the same one. Um, it's still cached. It's not going to give us an accurate doctrine time on how long this takes. But the one caveat to doing this is that I can see a permissions thing where it's like you don't have permissions to access this planet or this system, and so but you can get the stars for it. And so you would want to query the planet in that case to check the user permissions that the user can in fact access this planet. But um, you can just add uh, we can add logic to our through query. We can add criteria where we're going to have your user roles, they're just stored as an array for the user table or whatever, credentials table, whatever you're using. So you can just add that to the query to check, and you're really not going to have much of it's another select. You don't have to do it as a join. So you can have another subquery to check permissions instead of avoiding querying, this huge table. And the reason why this stuff matters is it's like, yeah, okay, we're adding another subquery to query users table, but it's like that users table, it might be 20 people, it might be 100, it might be 1,000, it might be 100,000, but it will definitely be probably your smallest table. Most people's user credential table or whatever is the smallest table in their database. And maybe there's a couple abstract ones that are really small, but they're generally really small. So that's not a very big performance impact to do a subquery, a subselect on a small table. But querying planets, I mean, that's going to be, in the trillions. If this was the Milky Way galaxy, that could potentially be in the trillions. Stars will be in, it'll be several hundred billion, half a trillion. So that's kind of the whole idea here, is to do everything in a really efficient way. But this has been a super long video of kind of just everyone watching me struggle. But I hope you enjoyed it. And I probably am going to look into how to actually recreate this with DQual somehow without sending it entities, just sending it IDs. And that's really the limitation, is that we have to add expressions and things to get around the fact that we're not passing an entity. We're just passing a random UUID that we're saying belongs to this base entity. But um, that's all for now. So I will catch you guys later.